Okay, to do the first part of this question, you need to know a couple of important facts about sines and cosines, particularly related to 180 degrees. Now, you should know that sine of 180 minus x is exactly the same as sine x. And it's easy to sort of show that diagrammatically by thinking about the graph of sine. Okay, so here's the graph of sine between 0 and 180. So there's 180 degrees there. If we have an angle of x degrees where x is acute, to find its sine, we're going to read that off here on the axis, the y-axis, which is the sine axis. If we've got, and this distance from here to here is what we call x. Okay, if we do the same thing up this end, so that this distance here is x, and we go up to the graph, we can see that the value of the angle here, which is in fact 180 minus x, is exactly the same. So this value here, by symmetry, because this curve is symmetrical, okay, these two shapes are exactly the same. The value of sine x is going to be exactly the same as the value of sine 180 minus x, and it's going to be the value here. Now, if we look at cosine, so similar idea, the graph of cosine does this, and the graph has rotational symmetry between about this point here where x is 90 degrees. Now, if we look at angle x, let's say we've got an acute angle here, x. If we're going to read off its cosine, that would be here. So cos x is going to be here. Okay, in this case, we have sine x, but it's actually equal to sine of 180 minus x. Now, if we want to find the cosine of 180 minus x, so that's going to be an angle which is here somewhere, so there's 180 minus x, so that this part here is x degrees. If we want to find that value, we would need to have to go down to the graph and across, and what we should see is, because of the rotational symmetry of the graph, down here we have cos of 180 minus x, and the value of that, this value here, is going to be exactly the same as this value here, but this one will be negative and this one will be positive. So in fact, the cosine of 180 minus x is the same as the cosine of x, but it's negative. Okay, so let's go back to the original question, which says show that cos alpha is minus cos beta. Now, if we look at the relationship between alpha and beta, we can see that because they're on a straight line, they add up to 180 degrees. So we can write that cos alpha is exactly the same as cos of 180 minus beta, because alpha is the same as 180 minus beta. And using this identity here, the cosine of 180 minus something is minus the cosine of the angle. So in this case, it's the same as minus cos beta. So cos alpha is the same as cos of 180 minus beta, but that is minus cos beta. Okay, that gets you your 2 marks. Okay, to do the next part, they're asking you to do the cosine rule in this triangle here. What I've done is I've redrawn this triangle here, so I've labelled it A, B, C. So for the normal cosine rule type triangle, this would be side C, this would be side B, and this here would be side A. But in this case, they're calling A over 2. So the cosine rule for this triangle, well, alpha is this angle here. So the cosine rule version that I'm going to be using is cos C is equal to a squared plus b squared minus c squared divided by 2ab. So quote that first. So cos c, so in this case c is alpha, so cos alpha is going to be, right, a squared, well, instead of a squared, we've actually got a over 2, so I'm going to write a over 2 squared plus, well, b squared is actually in this case called x squared, minus c squared, well, actually that is called c squared, and that's divided by 2 times, well, a in this case is a over 2 times b, which in this case is x. Now it's a bit of a mess, I've got to tidy that up and get it to look like that. Okay, so if we just carry on simplifying that then, this becomes a squared over 4, so you square the top and the bottom, plus x squared minus c squared. The bottom here, the 2's actually cancel, so we're just left with ax. Now to simplify that, I'm going to add the fractions at the top, so I'm going to think of each of these on the top as that is x squared over 1, that is c squared over 1, and I'm going to rewrite it so all of those are over 4. So the a squared doesn't need to change. Here I've multiplied the bottom by 4, so that's going to become 4x squared. I'm going to multiply here, I've multiplied the bottom by 4, So I multiply the top by 4 to give me minus 4c squared, and that is divided by ax. And effectively what I've got now, if I think of that as ax over 1, I'm doing a fraction, so I'm doing a squared plus 4x squared minus 4c squared over 4. And the way that I divide by a fraction, so I'm dividing by ax over 1, but multiplying, dividing fractions, ax squared plus 4x squared minus 4c squared over 4. If you want to divide by a fraction, you multiply by the fraction turned upside down. So the 1 goes there and the ax goes there, which leaves us now with, on the top, a squared plus 4x squared minus 4c squared, and on the bottom 4ax. So in fact, there is my expression for cos alpha as required. Okay, I now have to do a similar thing to part 2 as in part 3, and I've got to find an expression for cos beta. And to do that, I'm going to use this right-hand triangle rather, which I've renamed. So I've renamed M as B in this case, just to make life slightly easier. So again, for the usual cosine rule, that would be side A, and this would be side C. So again, cosine rule goes cos beta. Now in this case, cos beta is the same as cos B, and that's going to be a squared plus c squared minus b squared divided by, this time, 2ac. So in this case, cos beta is going to be, well, a squared is going to be a over 2 squared plus c squared, well, that's called x squared, minus b squared, that's exactly as it should be, and on the bottom here it's 2 times a, but in this case it's a over 2 times c, but c is actually x. Now we're going to get, so just removing the brackets there, a squared over 4 plus x squared minus b squared, and again the 2's cancel and we're left on the bottom with ax. Now I'm going to tidy that up in the same way as I did before. So common denominator on the top is going to be 4, so that becomes a squared plus 4x squared minus 4b squared, and that's all divided by ax. And I can see the same sort of thing as I did over here. The top is just going to be a squared plus 4x squared minus 4b squared, and the bottom becomes again 4ax. So that's my expression for cos beta. Okay, part 4 asks me to use the expressions from part 1, part 2 and part 3. To make it easier, I've written them down. So we've got cos alpha is minus cos beta, and we had an expression for cos alpha and an expression for cos beta. So I'm going to substitute these two into the first one. So instead of cos alpha, I'm going to write a squared plus 4x squared minus 4c squared over 4ax, and that is going to equal minus cos beta. So I'm going to write it as first as minus, so we've got a squared plus 4x squared minus 4b squared divided by 4ax. Oops, 4ax. Now I think the neatest way to sort out the right hand side there, let's just copy the left hand side, so plus 4x squared minus 4c squared divided by 4ax. The neatest way to make this expression negative is to actually just change the sign of everything on the top. So the top, so the minus 4b squared is going to become positive, because remember, a minus sign in front of a bracket changes the sign of everything inside it. So then minus a squared and minus 4x squared. I'm not going to change the sign on the bottom, only the top. Okay, so I've got 4ax. Now what's nice here is that if I multiply both sides by 4ax, the 4ax's disappear. And if I look at how the answer wants to end up, I want x squareds and a squareds on the left. So I'm going to keep my a squared plus 4x squared there, and I'm going to move that in a second. So I'm going to add a squared to both sides, so that's going to move over to there. I'm going to add 4x squared to both sides. I'm going to leave the 4b squared where it is, 4b squared, and I'm going to add 4c squared onto both sides, like that. So the left hand side becomes 2a squared plus 8 x squared, and that's equal to 4b squared plus 4c squared. And if I divide both sides by 2, I'm going to get a squared plus 4x squared is equal to 2b squared plus 2c squared. And if I just tidy that up a bit, I've got 4x squared plus a squared, so it's exactly how I want it to look like. And I factorise the right to make it 2 brackets c squared plus b squared. Okay, if we just look at the last part now, you might think it's got nothing to do with it, but it says you've got a triangular lawn, and the triangular lawn has sides of 46, 26, and 27 metres. Find the distance from the midpoint of the longest side to the opposite corner. Now, if we draw that, it sort of makes a bit more sense. So if we have, here's our triangle, and let's have the longest side down here, so that's our 46 metres. So the longest side here is 46 metres. Let's have this side as 27 metres and this side as 29 metres. And the question says find the distance from the midpoint of the longest side. Now here's the longest side. If we find the midpoint, that is here, and we want the distance from there to there. Now we have just proved in part 4 that 4x squared, now in fact x, if we look at our original diagram here, x is the distance that we want. And in this case, we can see that actually C is 27, B is 29, and A is actually 46. So that is A, because A over 2 is each of these, so the distance from there to there is actually A. So if we go back to this expression here, we can see that 4x squared plus A squared, well that's plus 46 squared, is equal to 2 times C squared, well that's 27 squared, plus B squared, which is 29 squared. So all I've actually got to do is stick that into my calculator. Now if we work it out, so we've got 4x squared plus 2,116 is equal to 2 lots of, if I work that out, it comes out as 1,570. And 4x squared then, if I figure that out, 4x squared comes out as 1,024. Dividing by 4, x squared is 256. So in fact, x is the square root of 256, which is 16 meters.